All right, happy Wednesday, everyone. Welcome to Planetarium's live star stream. My name is Levent Kürdemir, UTA Planetarium astronomer and director, and here Jim Bader, program coordinator. We are here again on Facebook,
Hey,
and we already have a question from Janet about our YouTube show. The YouTube show streams on Fridays at noon, 12. And it is not the copy or the same content as the Facebook. We are talking about different things. So if you don't mind, please check us on YouTube as well. And
at the very least, you could just go over to our YouTube channel and you could drop us subscribe. You could mash that like button on any of the videos you see. We got tons of videos we made over the last couple of years. So, yeah, check it out.
all right, today is October 27. It's we woke up with nice rain in our area, and then we started feeling slightly cool weather. But still, I see a lot of clear nights, and there's a great chance of view of Venus, Saturn, and Jupiter. And as we said before, you don't need anything other than a set of eyes to view that. And of course, the moon is giving a great show too. Some of the audience I see, hi Lamia, good to see you again. And Rebecca Elizabeth is with us. We already, I think, said hi to Janet. And also, we have some great topics to cover, and some of the things we wanted to bring up is some of the recent space missions, because years ago somebody asked me to write an article. It was actually a newspaper interview about what NASA is doing nowadays. That was shortly after the space launch's retirement, so the NASA was very popular with those space missions, the launches of the space rockets, and after they retired their fleet, the question was, okay, is there any job left for NASA? Of course, I mean, there are tons of things, but a lot of things that NASA is doing is still today, unfortunately, going unnoticed. And one of them is the recent mission called Lucy. So Lucy is a mission that the rocket, a space rocket, launched from Florida, Cape Canaveral, and it is on the way going to some asteroids. So asteroids are very popular. One of the recent asteroid mission was done by the European Space Agency. It was the mission was completed a long time ago, and since then the asteroids are actually main focus of space agencies. Well, currently we are trying to find out some of the characteristics and some of the special features of these the asteroids, but also they carry a lot of potential for future, because there is some field called astro mining emerging, and astro mining is actually getting some of the resources, some of the elements that are very rare on Earth from the asteroids. What you can find in the asteroids, there's a lot of things, including diamonds even. Yes, you can bring diamonds to Earth if you use robotic explorers. All right. So before we dive in, Patricia asks, do you know where is Star Watch Party in Dallas? Well, we actually have an observatory on UTA campus, and time to time we do some public events. Uh, we don't have anything on the schedule yet for the next public events, but check our website or follow us on social media, because that's a great opportunity to access I mean, the public size telescope. It's not a research telescope, but it is considered a great telescope for public viewing. So you can come when the next star party happens. All right, so apparently Lamia has a lot of background about what we are talking, because she says, I didn't know what is meant by Trojan asteroids. Can you please elaborate what does it mean? Well, first, I don't know why they call it Trojan asteroids, but those are the asteroids different than the ones are located in the asteroid belt, and also the different than the one in the Kuiper belt, which is towards the outside of the solar system. So with the Trojan asteroids, we are talking about the asteroids or the pieces of rock particles like these and perhaps like these located on the orbit of Jupiter. So here's the Jupiter's orbit, but they are not randomly located or uniformly distributed along the orbit of Jupiter. We are finding them on the special gravity locations in the orbit that we call L4 and L5. So L stands for Lagrange. Those are Lagrange points. If there are any the physics students, especially the graduate level physics students, they should know the Lagrange points very well, because those are a very big topic in mechanics. So those points, what they are actually some points that they allow materials being gravitationally balanced. So if you put any piece of rock on the orbit of Jupiter, it would get disturbed by the sun, by Jupiter itself, and by other planets as of their gravity. But here are the balance points of the gravitational balance points. So those pieces are not really affected or disturbed by the gravity of others. So that means with Jupiter, as Jupiter orbits on its orbit, they also orbit at the same speed, and they never change their relative position respect to Jupiter. And these particles can last forever on the orbit. So if those parts can last, that gives us the clue. Those particles may be, and probably is, but it's still a theory, that the particles coming from the early stages of the solar system, from the birth of the solar system, because the main theory is how planets form. The sun formed at the center of the solar system from the same cloud. The planets formed, but first they formed a debris field like these, and then the debris combined and attracted each other to form bigger body of the planets. And over time, the planet forms and orbits on its orbit, and it sweeps down the orbit as it goes. So no particle left after some point in time. So the solar system is old enough to pass that stage. So we don't have a lot of debris fields along the orbits. Well, we still have some, but it's a very minor thing. But because of the special gravitational balance and they follow the same speed on the orbit, these debris fields never disappear, never be swept by Jupiter. So this is what we call Trojan asteroids. All right, so because they can carry the clues of the early solar system, NASA scientists and engineers are wondering about these asteroids. So that's why there was a mission. It was proposed, designed, and then the spacecraft or the satellite, or it's a flyby mission. So they will not land on the asteroids, but they will just fly by. So NASA is taking a look. It's going to take a long time. I think the mission will be completed in like nearly 20 years. So and it is pretty much there are several years before the spacecraft reaches to the first asteroid. There will be actually one regular asteroid in the asteroid belt will be visited, and there will be 7 Trojan asteroids on the orbit. So it's a very, very nice mission. and also, yeah, there are 7 Trojans, and 4 of those are actually also the binary systems. That means like there are 2 asteroids. They also orbit around each other. So not everything in the solar system goes around the sun, like moon goes around Earth. And also there are some asteroids. They also orbit around each other.
It's super interesting, Levent. I'm pretty excited about it. We have all these asteroids it's going to go visit, and then the names of them are also related to early signs of ancient ancestors. And by that I mean like mummified remains that they found all over the planet, and then early hominids, and so on and so forth. Lucy, the name, comes from the early ancestor hominid. Very famous fossil find in history, and it's kind of neat that they're looking for the primordial makeup of the solar system for sure. I think so anyway. They're gonna go out and see all of these asteroids. Definitely pretty neat.
Certainly, and we talked about these Lagrange points, L4 and L5, and when we talk about in the future about Webb telescope, the new telescope in space, L2 point will become very important. So we can just introduce these when we talk about that topics, but there is like sun and planet. It can be Earth and Jupiter, and typically there are 6 Lagrange points around 2 body system. So L1 is between the sun and planet, and L2 is being on the other side, which is going to be the Webb Space Telescope located, and L4 and L5 are similar to the Jupiters. So yeah, it's a very interesting topic. So, do you have anything else? I think we have some other
Definitely.
missions too, right? Now,
Yeah,
NASA is
definitely.
not the only one working in space.
No,
But
we have some
also,
updates.
which one is this?
This is called Beppi Columbo.
Very interesting name.
Yeah, it is. It seems like it to me, but it's named after Beppi Columbo was a scientist, Italian scientist who he was the first one to really put in words that we could use gravity assist to get somewhere. So instead of burning a ton of fuel to get to a place and then having to burn a ton of fuel to get in orbit, that you could just really slowly and carefully use gravity to pull you into orbit, or gravity and to push you to another part of the solar system. So we saw in the orbital pattern of, if we go back here, it's going to go from one Lagrange point back to the Earth's orbit, doing a couple laps, and then shoot over to the other Lagrange point, which is insane. And it doesn't have to use very much fuel to do so, because it can just use gravity assist from the other planets. Pretty spectacular. Well, Beppi Columbo, the space mission, not the person who came up with that concept, is just a lot more wild, a whole lot more wild. It takes a long time for this mission to go through, 7 years just to get to Mercury, and I think that we know it takes 18 months to get to Mars. It's wild to think how they do this, but we can kind of jump into that.
So apparently, years after, they are going back to Mercury. That is great. So the Mercury, it's not the first mission to Mercury, because the first mission was
Messenger.
remember it was Mariner 10.
Oh yeah.
Back in 50s. So space missions started back in 50s, if you can believe. And there was in 2004 there was another NASA mission called Messenger, which maybe you can remind me the acronym of the Messenger. I think I do believe that they first make the acronym, and then they make up the whole words. And the Messenger stands for something like in a Mercury surface exploring something. It's a long,
Yeah, it is.
Made up name.
Mercury space environment, geochemistry ranging.
Yeah, Messenger. They wanted to call it Messenger, and they made up the rest. That's what I think. But anyway, the Messenger would also fly by mission to Mercury, And apparently, European Space Agency and the Japanese Space Agency came together because they were also wondering about Mercury and designed another mission, which is also launched and it's going on its way. Lamia, can it survive the heat on Mercury? Well, certainly, as we get close to the sun, the level of, regardless we are on Mercury or not on Mercury, the environment gets pretty hot because the intensity of the sunlight goes high. So yes, they can design the spacecrafts, which started with Mariner 10 in the early 50s. They can design electronics and the satellites that they can stand the heat of the sun. I think one of the criteria that they never point, if there's like a detector or a camera, they never point it to the sun because it's too bright. They can burn the electronics immediately, but otherwise, yes, I mean, there were missions designed a long time ago, even that they can stand heat. So, what are they looking at? The Mercury is actually very interesting because the Mercury has, as we know of, Mercury has a very large core. It's like a very big core of the planet on a thin crust. So, and we are wondering why Mercury has a big core. And the surface features of the Mercury is also very interesting, but some like we don't see a lot of volcanic activity on the surface of Mercury, but it has a large core and it even has a magnetic field. So those are some of the things that uh, we are trying to understand because we are trying to get better understanding of the solar system, how the planets formed, and the Mercury. Well, we know by other characteristics, it's a very interesting planet. It is a tidally locked orbit to the sun, and it orbits around the sun in 88 days. And when it completes two orbits, it is on 3 days on Mercury because it spins very slow. So that means 1 year takes about 1.5 day on Mercury. So we don't need spacecraft to explore all of those, but we are wondering about the interior of Mercury.
Super, super interesting. It does, it's definitely going to get hot there, but the spacecraft is designed to withstand temperatures of 350 degrees for extended periods of time.
Yeah.
Which is, I think that's what they're anticipating to reach. Reading into it, this you guys can see is crazy. This is a super wild event. This is the path it's going to take. From behind you, it starts at Earth. It does 2 laps around our orbit, meets Earth again later on the other side. Finally comes in, met Venus. It did this before. Then it comes back around and meets Venus again. It's already done that. And it finally, as we've seen, it finally hits Mercury. And it took some pictures of Venus on the way through, but they were super cool. And it was early on in 2020, so we didn't really report on it.
Yeah, this is brilliant engineering because there is no straight path to Mercury. Otherwise, you design a spacecraft which you have like unlimited fuel and the propulsion engines. So this was actually thought in the early Pioneer and Voyager missions. Engineers were wanting a spacecraft that was going to be flying through the solar system and visiting each planet on the way, like pretty much like our Secret of the Cardboard Rocket Planetarium show. There's an imaginary cardboard rocket that flies in the solar system with the kids and visiting each planet. So engineers were imagining something like that. But with spacecrafts being so small, at the maybe like a size of a car, the size of a bus at most, how are you going to store all that fuel? And you cannot just put big engines on it. So that became a very big challenge. But somebody came up with a brilliant idea and said, like, what if we use gravity to assist the spacecraft? And that enabled actually sending the spacecraft and robot explorers to way outside of the solar system, which like Pioneer and Voyager, they're about to leave the solar system. But how does it work? It works like first you aim your spacecraft from the origin, Earth, to the first available planet around. It's not crash landing into that planet. It is just going nearby. As it gets close to that planet, it speeds up. It speeds up that way. It when it passes the planet over here, it already gains the speed, but also this gravitational attraction make correction on the course. It bends the route. So you align it that way, you can calculate, the engineers calculate how much speed it is going to gain and how much the path is going to be bent. And it will be bent just that much, it will be aimed toward the next planet on the way. It will slow down for a while, but when it gets closer to the second planet, it will speed up again, and it will not crash land in the planet. It is just precisely calculated that way. It will pass by speeding up, but also the planet's orbit will be altered, bent again, and now you have to think about the third planet on the way. And if you do it for the, you can do it for the entire solar system. Yes, it is engineering amazing, and believe me, it takes a lot of calculations. And other engineers checks your calculations over and over and over, but they can design something that worked for many spacecraft. Apparently, it is going to work for the Beppi Columbo too, because it worked for Pioneers and Voyagers, both 1 and 2.
And that is precisely why they called it Beppi Columbo, because it is
Yeah.
going to take so long.
Mhm.
And Beppi Columbo is the one who came up with what you just talked about. So
Exactly. I mean that's
pretty interesting.
they call it gravitational assist, and it is an free, first of all, free and amazing system of flying spacecrafts all over the place in the solar system. There is one drawback though. You cannot design manned missions as by gravity assist because it only works one way. You cannot design something that will, let's say, take off from Pluto and come back to Earth.
These also typically take a long time to get through.
Exactly.
So yeah. Anyway, you talked about the mission wants to study the insides and the outsides of Mercury, learn more about it. It's a really complicated spacecraft. It is going, the image we showed initially.
Mhm.
We can light it back up, but it's in one piece. This is how it goes as it's cruising. So currently, but when it gets to Mercury, it breaks up big time. And there's two main spacecraft here that make up. There's the one at the very top. That's the magnetospheric orbiter, which is run by JAXA, or the Japanese Space Agency. And then the piece at the bottom, which is the primary chunk of it, and that one is the
This is not
planetary
part of
orbiter. Yeah, that's
picture.
not
Sorry.
the rest of it has its important parts to the whole ordeal, but they're even going to have different orbits, which is kind of wild to me. I think I have an image of that. No, it's maybe here. Yeah, these two chunks are going to even have different orbits. So pretty wild how they're going to make all this work. Definitely spectacular, to say the least. But the reason I think we wanted to bring it up is because we finally got pictures of Mercury. These are new up-close pictures of Mercury. This is what it did on October 1st, and certainly will put it back on my radar. I had almost completely forgot about it, and then we just kept missing it in our news or Ask Our Astronomer shows. And we can see really, really detailed images of Mercury, and they're only going to get so much better because these are with the spacecraft still crammed together.
Absolutely. I think we have a question on the chat before we continue with Rebecca's question. Is there anything on your list, Jim?
In regards to
about?
this?
Yes.
I'm sure I could talk more about this for a long time, but yeah, we kind of skipped. It seems like I tried to highlight it for you, but we somehow skipped Rebecca's question.
Okay, let's continue with Rebecca's question. My son has found a telescope online that uses an iPhone. Are they worth getting? And it's under $200. He's been bored at home. Well, telescope is a great thing for somebody bored at home in the evenings. Because most of the consumer telescopes are designed for use at night. There's also solar observing telescopes, but they are pretty expensive, require special solar filters. You cannot use regular telescope for solar viewing. So be careful not to point any optical object into the sun. But for at night, yeah, it's a great hobby, great thing to own a telescope, but yeah, the price is very important. So iPhone actually has not a significant option over here. Yeah, I started seeing more and more telescopes coming with a smartphone introduced in the picture in the box, but that actually doesn't mean anything because like the telescopes, most telescopes come with electronic controllers. So there are some motors built into the telescope's mount that point the telescope for you. And they used to include a handheld controller, which is a computer piece. Those handheld controllers were connected to the telescopes by wires. And I think to eliminate the cost of a microcomputer and a cable, they switched the technology into a smartphone. Of course, they are asking to use your smartphone. So if you are using your own computer in this case, they are not selling you that computer. And it is connecting via Bluetooth or Wi-Fi to your telescope's controller, and they designed an app, and you are using your phone as a handheld controller of the telescope. So I mean, it's not much different than being handheld controller. I like personally physical handheld controllers a little bit more, but the phone is not gonna hurt. Are they worth getting? Yeah, it depends on what you are going to use your telescope for. If you're on the market for a telescope, you have to do research. I have done a video a long time ago, and I think we need to refresh our video with more up-to-date information. There are some type of telescopes that they can be very cheap, but it can be very frustrating to point the telescope to some place in the sky. But there are some great beginner telescopes. Of course, you don't want the most expensive telescope you can afford as a beginner because there's a big learning curve. Telescopes are not like a pair of binoculars that you can just, I mean, you can technically point and see, but there are some things that you need to learn on your telescope when you own one. I promise, make a video about how to buy a telescope for like a beginner's guides of a telescope. All right, I think we are just doing well over time. Let's see if there are any other questions or comments from our audience before we conclude this presentation for now. And let me give you some teaser for the Friday. We'll talk about North Star on YouTube this Friday. And and that's going to be about how to find North Star. Why do we call one particular sky in the sky North Star? Was that North Star always, or it just became North Star in the past, let's say a few hundred years? We'll talk all about those. And also we'll talk about how our ancestors used stars, particularly North Star and other stars, to travel across the world, and how did they navigate their ships using stars. All right, so hope to see you on YouTube Friday, and next week, Facebook, the same time, we'll be here with another space news, space topic. For now, bye-bye.
Right. Thank you.